Hello, so we're going to continue this lab, and we want to be able to make pie and bar charts of sample proportion of interest. So, well, this is the second time I'm working on this video, so I already have my charts there, but I'll show you how to make those charts. So where we left the data set was we had it subsetted according to the two categorical variables, males and females in my case, and not text while driving and text while driving. And so we did already, count, do counts for these. So the females, I had 64. Since I had 100 pieces of data, I knew the males was 36. So now that I know that, I have that information, if you just type that into the cells, select the cells and do an insert, you can go here to a two-dimensional column chart. And so there it is. So I have the males and females. It'll pull this text right into the category labels, and then you give your chart a title. So I did that. Once you've given the chart a title, you can select the chart and do a copy and then paste it into a Word document. Okay, so you could do that with both of your categorical variables. My other categorical variables were texting and not texting, and again I added them up. We did this I think already in other videos. You just use the summation, equal to and summation. So the number that not text while driving was coded as a 1 in my data set. So I added those up. There were 68 of those, which meant 100 minus 68. There was 32 of the people who texted that have ever texted while driving. So if I select those cells, do an insert and a bar chart, then I have not text and text, the category names come up, and then again you have to give a title. So I've done that here. I gave a title, and once you do that, you can copy and paste it into your Word document. Okay, so that part's finished, and we could have done pie charts as well, if those are of interest. I mean, it says pie charts / bar charts. I think I'd rather just leave it at bar charts. I don't think pie charts are quite as informative. So I want to work on the confidence interval calculation for the population proportion. So that's the next thing you want to do here. And so you need to define what the proportion is that you're going to give a confidence interval for. So what I did is I selected, or I identified rather, the population that I'm working with is the population proportion of college students who have ever texted while driving. Okay, so that's the proportion, that's the P that I'm developing a confidence interval for. And you would need to do the same thing for your data and your questions. You would need to identify the proportion that you want to work with, because there's lots of different proportions here that we could identify, and you want to be very specific about which proportion you're working with. So this is a proportion I'm working with. Yeah. So I need, my p hat. Now p hat is the sample proportion. So I need the sample proportion of students who have ever texted while driving. So that, well, actually, I think I'd rather change this to never. I think I want to change this to never texted while driving. So let me do that. Never texted while driving. So the proportion of students that have never texted while driving, our p hat estimate so our p hat estimate is going to be equal to x over n. So our x is 68, and then we divide that by n, which is 100. It's 0.68. I mean, that was obvious. So now I know what p hat is. So the next part of this is I need to identify what the margin of error is. So to do the margin of error, especially if we want to do this in Excel, we need the the z value, because this is a z distribution, and in order to do this, we need at least 5 successes and 5 failures, which we have here. This is, both of these categories are larger than 5. So we do meet the minimum criteria to use the normal distribution here. So we want Z 0.05. So Z05, I'll call it. So let's see, what's Z05? So to find that, again, I'm going to do equal to, and I'm going to go in f of x, and I'm going to sort of search here in the statistical functions, because there must be a boatload of normal distribution stuff here. And I'm actually, I must want this one, norm inverse. So let's see. Probability, standard deviation, returns the inverse of the normal CDF for a specified mean and standard deviation. Okay, so that's what I want. So the syntax is the probability. Well, since it's Z.05, I have a probability of 0.05 in a tail, so 0.05 is the probability. This is the standard normal, so the mean is 0, standard deviation is 1. So if I do okay on that, the probability I want is 0.05. The mean is 0, and standard deviation is 1. Okay, so that's what it is. We usually use 1.645, but instead we have that. Now we want the positive. So to force this positive, I think I can put absolute around it. So ABS is an absolute value function, and if I just surround this with ABS, then it's going to, force that value to be positive. So there's my Z 0.05. And then I think I'm ready to do my calculation. So to do this calculation, I'm just going to call this, what am I going to call it? I'll call it E, the margin of error. So this margin of error calculation, that's going to be equal to, well, I need the Z value. So I'm going to click on this cell because that contains the Z value. And then I have to multiply that by, I need the square root of P hat Q hat. Okay, so the square root function, I want that function here, and I happen to know the syntax for it, but suppose I didn't. I could go to f of x. I don't want statistical now. I want all. And I want to find square root in the list. So square root is right here. Okay, so square root. So square root of what? So I want to, I need this number, P hat, but then times 1 minus P hat. 1 minus that number. And then I have to divide that by n, which is, in this case, 100. I don't have n in my worksheet, so I can't identify a cell. So it's that. Okay, so if I do okay, I have the margin of error now. And I can see here the margin of error was calculated using the the G48 cell, the Z value, times square root of P hat times Q hat divided by n. And the square root, kind of like the calculator, the square root, everything in the square root needs to be in parentheses. Oh, it's actually like the old calculators. The newer calculators, you don't need parentheses for that. So now I know the margin of error. So here in my page, I did, now I have software that, will type, math notation. If you don't have that, you can leave the space blank. Leave the, you want to type the document, but the part where you need to insert math symbols, if you don't have that type of software, you can just write that in by hand. But in fact, I don't have that kind of software on this computer because this is my son's computer, but I do have it on mine. So anyway, P hat is 0.68. And I don't want that in blue, I want it in black. So I'm going to fix that right away because that's going to annoy me. And then minus the margin of error. So, in fact, I want a space there. So minus the margin of error. So I'll estimate that as 0.0767. and that's going to be less than P. Nope, I wanted to put spaces there. And then the same thing, only with a plus sign. We'll change that to a plus. So there's the confidence interval for P. And so I can do that, you know, in Excel, figure out what that is. So the lower bound, I have a lower bound and I have an upper bound. So the lower bound, that's going to be equal to P hat minus the margin of error. And the upper bound, that's going to be equal to P hat plus a margin of error. Okay, so those are the boundaries here. So I can just put those here. So I have okay, so I have that, and so that's approximately 60%. So I'll do this as 60% and 76%. So I need an interpretive statement here. So I am 95% confident that between 60% and 76% of college students have never texted while driving. And so that would be the interpretive statement there. But in fact, you know, since all this data is, well, the original survey was bogus because it was a convenience sample, and then anything subsequent that was randomly generated. I mean, this has no bearing on the reality of you know, what's happening with students at large. So, you know, just keep that in mind. Okay, so that's it for this piece.